Okay, so when we look at vectors, there's a lot of new words that have to do with vectors that are related to them. We got vector quantities, scalar quantities, a component form, which actually our book doesn't talk about component form. I just wanted to show it to you anyways. Initial point, terminal point, magnitude. Now for magnitude, I put these double lines right here because normally when you have a vector with the double lines around it, it's saying find this magnitude. Direction, unit vectors, rectangular coordinate form, which I like to also call unit vector form, and then the position vector. All of these, I mean, they're all important. I mean, but when we start working with it, they make more sense, and you have a better chance of remembering them. So let's just get right down to it. I guess before we go, though, I want to talk about the vector and the scalar quantities. Now, a vector quantity gives you the direction and the magnitude. A scalar quantity just gives you the magnitude. Now, a scalar quantity is pretty much any number. Any number that you normally have been, like any number, like 5, that's a scalar quantity. It's not a vector quantity. Why? Because it doesn't give you direction. It gives you a magnitude, but doesn't give you direction. And then when you talk about magnitude, you could talk about a bunch of different things. If you're in physics, you talk about force. That's how much force you're applying to it. If you're, I think physics also talks about like velocity. Velocity can be a scalar quantity, okay? Because it's telling you like, or it could be a magnitude is what I want to say. And so that's what those words mean. It's kind of weird because you don't use them every day, so you're not going to remember them that well. Except for maybe the rest of this unit, maybe the rest of this week. So here we have our unit vectors. We have I and J. It's important to note that I and J are these single unit vectors, but they go in a special direction. I goes in the direction of x, and it's only 1 unit long. And so the magnitude of this vector is 1, and it goes to the right. The magnitude of the j vector is 1, but it goes up. And we're going to use these two vectors to write other vectors. And that's called rectangular coordinate form. Component form is what some of you guys might remember from last year when you guys did one section of it. Component form looks like this. It's in these pointy parentheses. So like 1, 1, which would be 1 this way, 1 this way, and so our vector would be that. That would be component form. Okay. But now let's talk about this graph right here. In that graph, we see the two unit vectors, the I and the j, and they both have what you would call a scalar multiplying to them. So that a right there is a scalar multiplying to it, and that b right there is a scalar multiplying to it. And the reason why we have the scalars multiplying to them is because that helps us. It makes it so that we can work with them very easily. Okay, here let me give an example. Let's take this point for example. All right, no, not that one. Let's do this one. So this vector right here goes to the left 1, and then it goes up 1, 2, 3. Okay, this point is 1, 3. What's the vector? How are you going to describe this line right here? Well, we use the 1, and we multiply it to the I vector, the I unit vector, and then we use the 3 and multiply it to the j. This describes our vector. If we call this vector v, this would be vector v. Now, normally when you're representing vectors, the letters that you're writing are supposed to be bold. It's hard to bold sometimes, and some people that really bothers them, so they put little arrows right above the variables to say that they are vector variables. Is it that important? No, just it's important that you know that when it's bold like that, it's talking about vectors. So let's just look at some examples. Let's take a look at this first one. Now this vector is not at the origin. If it was at the origin, it'd be called the position vector. But we'll soon find out that this vector is still going to be the same as the position vector. So let's graph them. We have 4, negative 7. We go over 4, down 7. We have a point right there. And then the other one is negative 1, negative 5. And so we have a point right there. Now it's very important to know which one is the initial point and which one is the terminal point, because that tells you which direction your vector is going. So this vector is going this way because this is the initial, that's the beginning point, and then we have the terminal point. Alright, forgot to go down farther. Alright, so that's our vector that we're trying to describe. And how will we describe that vector? Well, let's use our unit vectors to name it. Okay, we're going to call this v, but let's define it. To define it, we have to take into account how much left it's going and how much up it's going, and then the distance between these two. And so, what we're going to do is you could count. So you could just go 1, 2, 3, 4, 5, and you could count 5. So it's going 5 to the left. And how would you represent 5 to the left? -5. That -5, is that -5 going to multiply to the j or the I? Which one represents a horizontal movement? The I. So it would be -5I plus. Now we have to represent the horizontal movement. So we would just the vertical movement, and then we go up 2. So it's 2j. That's not bad. That's our vector v. I'm trying to bold it. That's our vector v. But how would we do it without graphing? If I wanted to find those values without graphing, it would look something like this. You would have to find this distance, but you have to know that it's negative. So how would you find the negative distance? Because if I go 4 minus -1, 4 minus -1 would give me +5. But if I went the other way, if I went -1 minus 4, that would give me -5. And we want it to be -5. And so which point do we always have to have first? The terminal point. The terminal point has to be first. And so in this you would say, if you had a formula, this is what your formula would look like. This is our vector. Alright, now we're just trying to find this value and this value. We're trying to find the horizontal movement and then the vertical movement. So we always have to have the terminal point value first. And so we're going to have -1 right there, and then you would subtract 4. And that will give you your -5. And then for the y, you do the same thing. You do -5, then you would subtract -7. And that would give you the +2. This is the vector for these 2 points. Now, it doesn't ask for magnitude here, but let's go ahead and find it. Now, to find magnitude, you just have to find the distance between the 2 points. But the cool part about vectors is that this already gives you the distance between the x's, and this gives you the distance between the y's. And so to find the magnitude, it would look kind of like this. You'd write your notation like so. You put double lines around it, because if this is a vector, those double lines mean find the magnitude. And to find the magnitude, we do the distance formula. Pythagorean theorem. Same stuff. That would be -5, and that's 2. So we have to find c squared. So we'd go -5 squared, and the negative doesn't really matter there because when you square it, it goes away. Then we have 2 squared, and we got to take the square root of that. And so this would be 25 plus 4, and the square root of that. And so your magnitude for this is going to be the square root of 29, and unfortunately, we can't simplify this to make it look prettier. That's our magnitude of this vector. Now what I want you guys to do here is I want you guys just to pick one of these vectors, and I want you to find that vector. Like write it in the rectangular form, and then have your neighbor next to you find a different one and compare. Yes, these are, you notice that they're all the same magnitude, but what else do you notice? They're all the same vector. Now think about this. Vectors tell you the direction, and it tells you the magnitude. Force or velocity, whatever it is. All of these arrows point the same direction, and they all have the same length. Therefore, all these arrows represent the same exact vector. Now, which of these arrows is the easiest vector to find?
CD.
CD. Now, why is CD the easiest to find? Because it's at the origin. That vector is called the position vector because it's centered at the origin. Yay. Okay, well, let's write down the vector really fast. It goes 4, and then that's 3. And so it's 4i plus 3j. That's your vector right there.